One thing we spent a while talking about with Wireshark was the fact that it loved to help you out by doing certain types of name and port resolution. So it might resolve specific port numbers to common services associated with them, or maybe it resolves IP addresses to domain names, things that may be helpful for certain types of analysis, but again, another layer of abstraction you should be aware of. Now, TShark is much like Wireshark in that it attempts to do a lot of these things by default. So if you want to disable that functionality, you have to explicitly do so. And in this case, it's pretty easy. You can actually explicitly disable all name and port resolution in TShark with the -n command. And by appending that to your reads, then that will disable those things. Now, keep in mind, just because you capture packets with -n doesn't mean you don't need to specify that when you read those packets. This resolution is most often being done when you are reading packets out using -r, so you need to actually specify -n every time. I get in the habit of most every time I run TShark, I run it with TShark -nr if I'm reading files, or -ni if I'm reading straight from the wire. But you need to do it most cases if you want to disable it. Now, again, -n disables all of name and port resolution. That's lowercase n. You can use capital N if you want to selectively enable specific types. So by using -N, it's going to disable every type of name resolution except for the ones you specify by specifying an ID here. So if you specify the letter M, it will disable everything except for MAC address resolution. If it's N, everything except network address resolution. And you can combine these two. So you could do -N and then lowercase mnt with that. And there's no space here. This all needs to kind of butt up together. So these are just ways you can more granularly configure name and port resolution options. If I run the command we ran just a minute ago to view the first 6 packets of this capture, you'll notice that we have name resolution occurring here. Now, we don't have any host name resolution of IPs to domains, but we do see we have some transport layer resolution of port numbers to common services. So we see here port 80 in HTTP. If we want to disable that, we can do so pretty easily by specifying N here with the R command, so -nr. And if I do that and look at port 80, in this case, there's no more resolution going on. It just gives us the number, and that's all we have to work with. If we want to get more granular with what we're doing, we can specify the capital N command. So let's get rid of lowercase n. I'll add capital N, and let's just say I want to, let's just do something really simple. We'll just say to disable the use of, let's disable current, or specifically enable concurrent DNS lookups, which is capital C. So in this case, it's -nc, and I've appended it to the -r command, which is what you've seen me do previously, but that's actually not going to work here, and I want to show you why. If I hit enter, it's going to tell me that for the -n command, R is not a valid option. So with this N command, everything following it is interpreted as an argument of that specific argument in itself. So we actually have to separate these when we do this. This is something that tricks a lot of people up. So just by doing -nc and -r, if I run that, in this case, everything is going to work fine, and it's okay. We just have to be sure we separate those commands out. It can become really easy and really tempting to want to put everything next to R. I do that a lot myself. Generally, every time I run Wireshark, or excuse me, TShark, I run TShark-nr to read a file. But you have to be careful sometimes of how you combine those commands just based upon the way the different options work. Aside from capturing and reading data with TShark, the most common thing you'll probably do is apply filters to it. After all, that is one of the use cases I mentioned very early on that is probably my most common use case, is taking a very large capture file and filtering it down to something a bit more manageable so I can analyze it a bit easier, or maybe even open it up in Wireshark. So the question often is, can I use BPFs or display filters with TShark? And the answer is yes, you can actually use both of them. You just have to specify a different command line argument for each one you want to use. For BPFs, it's -f, so it's a lowercase f, and for Wireshark display filters, it's a capital Y, and then of course after you specify the argument, you put your filter in there as well. And you can put filters in a lot of different formats. There are a few best practices. I generally wrap mine in quotes, or just a single quote. Single or double, it doesn't really matter, but I do generally wrap them in some type of quote so they're a little easier to deal with, and I can break up multiple statements in a more logical way. Now, if I go ahead and run through this HTTP ESPN capture here, there's a lot of packets to look at, more than I would be able to reasonably look through for any type of meaningful analysis, at least on the command line, unless I'm doing something else with the data. So in this case, I want to apply a filter to it, and I can really do that in a couple of ways. Now, this http espn.pcapng file we've been dealing with has a lot of packets in it, really more than I can do anything with in a reasonable manner unless I filter that down or do some type of statistical analysis. So I need to find a way to get this down to a more workable set of packets. And I can do that by filtering, of course. And let's say I want to filter based upon just the DNS packets that are here. I can do that in a couple ways. One is just to use a simple Wireshark display filter. So to do that, I'll use the -Y option, and we will put quotes and do UDP dest port equals 53. That's one way to do that, and that works just fine. And notice I get all of the DNS traffic that's being sent to destination port 53. Of course, that means I'm only getting the request. I'm not getting the replies because the replies are sourced from destination port 53. So I can extend that filter if I so choose to. One other thing I can do is I can change it to be a little bit simpler, right? I can just do a filter that says, just give me the DNS traffic. And if I do that, it will actually give me both directions. So I can apply any display filter that I would apply in Wireshark here in the same way to TShark. You just have to use that -Y option. And I like to put those in quotes because that makes it a little bit easier to keep track of. And you can also play around with those as you combine more complex statements. Now, one thing you might be thinking is, well, I may be a little bit more comfortable with BPF syntax, so can I actually just apply BPF syntax instead? And let's see what happens when we try to do that. The command line argument for BPF syntax is -F, and I'm going to use that to say, let's say UDP port 53, which will get us similar to what we saw output earlier. But watch what happens when I enter that. Remember from our discussion on filtering that capture filters cannot be applied at read time in most cases. So I can't apply BPF at read time. I can only use a Wireshark display filter. This -F option can generally only be used with the -I option. So if I do that, let's go back here and let's get rid of this, and let's just say we're going to do capture off interface 1 and apply it that way. And if I do it that way, it looks like it's going to work. I'm not capturing any DNS data right now, so there's nothing to see here. But it looks like it worked and it was accepted. So that's the thing you have to keep in mind, is that display filters are for when you're reading data, and capture filters are for when you are capturing data. And that's what we're talking about when we're talking about BPFs in this case. Generally speaking, the Wireshark display filters are much easier to use in most cases anyway. So that's probably what you're going to get more used to using and feel more comfortable using as it is. But you can apply both of them in varying circumstances with the -Y and -f command line arguments. One thing we talked about a lot with Wireshark were the time display formats. And at this point in the course, we've not done a lot with playing with those. We'll do a lot more of that, especially when we talk about dealing with network latency and troubleshooting slowness. But in this case, time display formats are very important, and TShark allows you to manipulate those in the same way Wireshark can. You just have to be a little more specific in how you do it. It's not just a simple context menu option. You have to specify what you want to do. Now, that's pretty straightforward, and it's done with the -T option. And with -T, you specify what time you want to use by providing any number of the options on the screen here. So, for instance, you can use -TA for absolute capture time and local time. Say maybe you want it in UTC time. You can do -TU for absolute capture time in UTC. You can specify epoch time, time since beginning of the capture, time since previously displayed packet, a lot of these various options. You can do any of these, all the same ones you can do within Wireshark itself. The last feature of TShark that I want to show you is maybe one of the most impressive, and we often think about Wireshark's use in that it provides a lot of summary statistics and analysis related outputs from packet capture that really let us dig into the packets far beyond just scrolling through lists of them. And that's a great thing about Wireshark. And most people don't realize it, but TShark can produce a lot of the same output, albeit in the command line rather than in the GUI that Wireshark provides. And again, most people don't realize that, but it can actually do some pretty cool things, and it does this with the Z option. So -Z followed by the option of which specific output you would like to produce. Now, Wireshark, or excuse me, TShark has a lot of these options, quite a few, and you can list them all out with just by specifying -z help, and that'll give you all the different things you can do. But again, there are a lot of them. You can list them out that way, or you can go to the TShark help documentation to view a list of them. Now, there are a lot of these. Here are a few examples, a few of my favorites and things that we've talked about previously that you may be curious about. So, for instance, by doing conv, IP, you can list all the IP conversations. You can look at a list of HTTP requests. You can follow TCP streams. You can output protocol hierarchies, provide a list of IP hosts. Again, all these things that you would do in Wireshark, all capable within TShark as well. So let me show you a couple of those, and I'll also provide you a list of some of my favorites that I wind up using quite often. To get a sense of the power of the Z option, let's go ahead and just run -z help and get a list of all the output it can provide to us. And you know what? There are quite a few of them, it looks like. Now notice they're sorted by protocol for the most part. So we see we have some ICMP things here. We have IP, it looks like IPv4 there, or IPv4 and IPv6. We have some things using some words that we've seen familiar already. So we see endpoints from the endpoints dialog in Wireshark. We see conversations, and we can do those conversations by protocol. So we have a sense of kind of a hierarchy here in terms of you have the top level item followed by a comma, followed by the next item, and so on. And we have a couple degrees deep that we can go. So there are some interesting things here. So let's go through an example now of using one of these commands on a particular file that maybe is a little bit too big or too complex for manual analysis. So we really want to rely on these statistical features. So in this case, I'm going to go ahead and use the HTTP tree option, which is an option we could use in Wireshark if we went to the HTTP analysis section under its menu structure and outputted what it had to offer. Now, I'm on a VM here. It's a little bit of a limited resource, so it's a bit slower. You notice it has to actually parse all the packets to generate this data, as you might expect. It dumps those to screen here and then produces an output similar to what we might see in Wireshark. So see we have HTTP packet counter, and we're looking at the number of packets and percentages and rates of packets relevant to specific types of HTTP requests and responses here. So we see our responses up here. We see requests. It looks like all these were GET requests. So a very quick way to get statistical information. It's not formatted the absolute best due to the limitation of the size of the window, but you kind of see what's going on there. Now we have a couple other cool things we can run. One of those is packet hierarchy, which is something we've talked about quite a bit. So that's pretty straightforward. IO, PHS will give us the protocol hierarchy for this capture file. Once again, it'll take just a little bit to run since I'm on limited resources in this machine, but notice it gives us, again, something similar to what we would get in Wireshark. Now, we don't have the benefits of being able to expand and collapse these various things. It shows it to us fully expanded. We don't get all the fancy percentages. We just get kind of what we have here. So it's a little bit limited, not quite as good as Wireshark, but in a pinch, if this is all you have, this is pretty darn cool. Now, I want to show you just one more to kind of show off the power of this, and this is one I really like, is the ability to follow TCP streams. So I'm going to do that here, and notice I have to put in a few different options. I use the follow option. I say I want to follow a TCP stream, so the TCP option. I want to see that in ASCII, and then I have to give it the stream number. So in this case, stream number 0. So it's going to go through and do its magic on all these packets, and hopefully TCP stream 0 has something useful in it, and it looks like it does. So we see we have that information. It gives us a little bit of metadata, so it tells us node 0 is this 172 address, node 1 is the 68 address, and then down here we get the actual content of the data being transmitted. So this is a nicer way to look at this, just like you would follow a TCP stream in Wireshark. So pretty neat. So this option, again, this -z option is really, really powerful, and it has a lot of things you can do with it. So I would encourage you to use TShark-Z help and look at all these. Just start playing with them. Take some of the packet captures I've provided to you in this course and just start running through those things and see what value they provide to you. Again, you may not always have to rely on these things if you have Wireshark available, but if your packet capture file is too big or you only have TShark, it's good to know these things exist. I'm quite surprised when most people tell me, you know, I only have TShark. It'd be really great if I could run a protocol hierarchy. Is there a way to do that? And they don't realize that, yes, there is, and it's pretty straightforward. It's very simple, and quite honestly, once you're already at the command line, it's much simpler in some ways than running it in Wireshark. It's just a couple keystrokes. So very cool, very powerful option. That's going to do it for our section on TShark. Again, this wasn't too deep, too involved. Quite honestly, TShark has a lot of features, but really the ones you're actually going to use and the practical ones that exist are not too many of those. So it's really easy to go through this very quickly. And it's one of those things, the more you use it, the better you're going to get at it. One thing I would encourage you, don't be worried if you have to look up commands really often. That happens a lot, especially if you just don't use this stuff all the time. There's no shame in having to look it up in a manual. And TShark makes that pretty easy. You can just use the -H option. And if you do that, it'll give you the help data for Wireshark. It'll give you all the different commands you can use. And there are quite a few of them, quite a few we didn't cover, but again, we covered a lot of the practical ones. So you have the ability to look at those. If you want to get a little bit more involved, you can go to the manual pages for TShark. These are hosted on wireshark.org. If you actually just Google TShark, this is generally the first thing that will come up, and it'll give you some more descriptive output about the different commands and how they work. And it's all mostly fairly straightforward. These manual pages can be a bit intimidating because it's very, very verbose and it's a little dry. But I would start with the help output and then go from there. So that's your best places to go. So don't get discouraged if you're not too up on the command line. The more you use this, the better you'll get. And I'm such a fan of TShark. It's my preferred packet capture tool on the command line. I use it quite often for many of the use cases we've already discussed. So take a minute to play around with TShark and make sure you take a moment to do some of our labs and quizzes and such in this course as well. It'll really help you out, I think.